Hello, good day students. Now, in your previous video, you have discussed how to manipulate the exponent. So this time, we will discuss how we end up with the answers with your board exercises. So let us recall with your board exercises. In your board exercise number 1, you are asked to find what is 5 cubed. Now, 5 cubed is just equal to 5 times 5 times 5. And when we multiply 5 times 5 times 5, that is equal to 125. Therefore, 5 cubed is equal to 125. Now, this 5 times 5 times 5 is basically from the discussion in your previous video. If you have a to the n, or a raised to the power of n, that is equal to b, where our a is just the base, n is the exponent, and our b is the power. And when we say a to the n, that is equal to a times a times a times ellipses times a, where that a, it was multiplied n times. If you try to observe, that n times is just the power, the exponent of a to the n. So, just an example, if we have a squared is just basically a times a. On our second exercise, what is 5 to the 0? Now, 5 to the 0 is equal to 1. The reason for this is the 0 as an exponent, where the 0 as an exponent tells us that if a is not equal to 0, take note, a is not equal to 0, or the base is not equal to 0, then a to the 0 is equal to 1. Any number except 0 raised to 0 is just equal to 1. Now, if you are asked, or if you ask why 1? So let us recall on the law of the exponent. So if you try to remember the quotient rule for exponent, you have there a to the power of n divided by a to the power of m, that is equal to a to the n minus m. But what if if n is equal to m? Then it would result to 0. So just as an example, a to the power of 5 divided by a to the power of 5. Take note, they have the same base, then it is equal to 5 minus 5, or a to the power of 5 minus 5. And 5 minus 5 is equal to 0. Therefore, that is a to the power of 0. But if we divide a to the power of 5 all over a to the power of 5, if you try to observe, they are the same number, just like 10 divided by 10, 5 divided by 5, 11 divided by 11 is just equal to 1. Therefore, a to the 0 is equal to 1. So that is the reason why any number raised to the power of 0 is equal to 1. Now, and our last board exercise, you have there, what is 5 to the power of negative 2? Now, 5 to the power of negative 2 is an example of a negative exponent, negative integer as an exponent. So 5 to the power of negative 2 is just equal, based on our discussion on the integers, the negative integers as exponent, that 5 to the power of negative 2 would become a reciprocal or a fraction. It would become to 1 over 5. So to eliminate the negative, that negative 2, okay, from that negative 2, 5 would become a fraction, 1 over 5, and we will eliminate the negative on its exponent. So 1 over 5 to the power of 2. Now, if we multiply 1 over 5 to the power of 2, or if we apply the power product rule on the exponent, that is equal to 1 squared over 5 squared. And 1 squared is equal to 1 times 1, and that is 1. 5 squared is equal to 5 times 5, and that is 25. Therefore, we have 1 over 25. So, therefore, 5 to the negative 2 is equal to 1 over 25. Now, what did I tell you earlier about the negative integer? So this one, negative exponent. If n is any integer and a and b are not equal to 0, then a to the negative n would equal to 1 over a to the power of n, or raised to the power of n, and that is equal to 1 over a to the power of n. So that's what's happened. Okay? So if you have clarification, just ask your teacher right now, and he is willing to answer your queries. So good luck to your next discussion, and this is about the exponential equation. Bye guys. Thank you.